Hello and welcome to another episode of Robotics Programs in Elementary Schools. My name is Aiden Femeson, and this is going to be the second episode of this series. Last episode, we covered the podcast overview, the purpose of why I'm creating this series, as well as what skills robotics learn in robotics programs besides STEM skills. So if you missed that episode, I highly recommend taking a look and watching that one before diving into this episode. So for today's guest, I have someone very special when it comes to working with students in robotics. He is the Career Technical Education Department Coordinator at Los Altos High School, a wonderful teacher and team mentor for 114 Eagle Strike. Please welcome Stephen Hine. How's it going?
Good. How are you?
Busy, but excited to record this episode.
Good.
So, how have you been since the last competition your team competed in, as that was the last time we saw each other?
Yeah, it's been pretty good. The wind down of the competition season is always it's interesting because you get the mix of the seniors that are now done and they put in so much time, so you can tell they're just I'm done. Yeah. But then you also have the sophomores and the juniors that are just so ready to go for next season, and so they're trying to figure out what they can do to improve already. It's a great class. For those of you wondering,
Stephen teaches a high school robotics class. He runs, they're part of a program called First Robotics Competition. And just please let the viewers know what you kind of do here at Los Altos High School, as well as kind of the robotics programs you teach. Just a little brief.
Sure. So we have had our robotics program for I think 29 years now, but it was a club for a while. And so now it's actually a class, well, two classes. So next year we're going to have 3 first-year classes and 2 second-year classes that are part of the competition team. So it's basically like a whole freshman through senior program specifically about robotics. We are definitely one of the only high schools that does that specifically. There are a lot of robotics programs out there, but whether they have a 2-course sequence and that's specifically centered around competition robotics, that's not as common.
Yeah, and it's really exciting because this podcast is supposed to kind of help teachers use the information here to gather and convince their elementary faculty, like principals or the district, of saying, hey, I want to run an elementary school robotics after school program. And even though you are teaching high school, you do have a CTE credential. You have looked into these kind of after school programs before. So you're going to give out so much information. And I hope that if people do want to use this podcast to really help teachers convince not only themselves but their school, hey, I want to run this after school robotics program. Here's the information we have. You are the perfect person to do so.
Yeah,
so,
hopefully.
Stephen, we have a lot to talk about today. A little bit more than I have more to talk about, but we only have so much time. Yeah. So I hope you give us some really great insight to robotics programs, and let's just go ahead and start off with current programs that we both kind of know or that we've worked with. The first program we're going to start with is FIRST. Mm-hmm. For those of you watching, FIRST stands for Inspiration, Recognition, Science and Technology. It is a program for all ages of school, K through 12. And there are 4 programs in in FIRST. There is First Robotics Competition, which is the one you help with and you run for high schoolers. There is First Tech Challenge for middle school and high school, and then there's First Lego League and Junior First Lego League. So kind of the main one we'll be looking into is First Lego League, because that is geared for 1st through 6th graders around that angle. And what First Lego League is it's a yearly challenge, usually themed, where students have 2 main objectives of the challenge. The first one is to build a robot out of the Lego Mindstorms kit to then do some tasks on a field. And then the other challenge is research project to present to judges and kind of tell them that their findings about their creative ideas to maybe fix a first world problem or address a challenge. What else do you know about First Lego League that you might be able to share?
I don't know too much about it, but I have a bunch of students that always come from it. Right now, one of our captains this year was actually one of a regular champs attendee, I guess. Her team was amazing. And just hearing what students do in that program, like you said, it's from the Lego Mindstorms kit, and I remember when the first Lego Mindstorms kit came out when I was like super young, and so it's really, and I remember getting that kit thinking, oh wow, you can do so much with this. Like Legos can be robots.
Yeah,
what?
That was also surprising to me too growing up.
Right. Yeah.
When I first participated in the program, my friend, he was telling me, Hayden, do you want to do this robotics program with Legos? And I was really confused. I was in fifth grade at the time, but it was wonderful. They're super cool, and they're way more advanced now.
They are.
Yeah.
Yeah. I mean, there are even some like circuit Legos now too, right? There's all sorts of stuff. So I think it's so cool giving kids an opportunity that young to be able to put their hands on things, build things, start seeing how motion works, how mechanisms behave and interact with each other. And you don't even have to like do a good job necessarily. You can just build things and just see, does this even work? Which I think at like a question about like kindergarten and first grade, that's all you really need at that point, right? You don't need them to be successful. You just need them to try stuff.
Absolutely. And one of the things I love about First Lego League is the opportunity of research and talking to judges, and the competition more, instead of feeling like a competitive, you always want to win, it's more of creating friends and creating community and kind of just spreading ideas around, which is what I really love about First Lego League. Again, I'm going to talk about the research project because that is something not looked at a lot. In the first episode with Douglas, we talked about skills other than STEM learned in robotics. This includes Douglas really had a big point on project management, time management. Even students as young as in first grade to fourth grade, learning how to manage their time is also really important because it's something where in traditional schooling you don't really get to experience.
Not at all.
Managing your time, managing a project. Another one is teamwork. Teamwork skills was a big skill. Again, if you guys haven't watched the first episode, we talk about in depth of the skills learned that are both STEM and non-STEM, kind of what you learn in robotics competition, in a robotics program. But what I really like about the research project is there's always a theme, and then it's always about students' original idea. When I did the FLL program in elementary school, I did it for 3 years, and one of my favorite years was in 2015. The theme was all about recycling, and the reason why I remember this one so much is because our team was like, we want to learn more about recycling. Where do we start? And it was just as simple as going to the garbage area in our town, going to the recycling center and just kind of learning about how the workers recycle and reuse and process all the trash. And it was just really cool, and just getting the opportunity to go and expand our learnings is really important. I feel like elementary kids, some of them are just kind of sitting in class, kind of feels like a daycare at some points, where an after-school robotics program like First Lego League can really help with getting students exposure to different type of ideas.
Absolutely.
And I think that's really cool that half of the competition is kind of a research project where students get to talk about their ideas. Another one is there was a year about natural disasters. And when I went there, I saw so many different teams, just students just talking about ideas for these natural disasters. And they've drawn out and laid out kind of solutions that they've invented. And it's just super cool.
Yeah.
So I think robotics program, yes, it's all about robots, but at the same time, those other skills and those other opportunities to learn about other things can really help students grow, especially when they're still growing in the brain and learning all these different type of abilities and all these things. So that's kind of like what I really like about FLL.
Yeah, well, and those skills transfer from program to program throughout the first system as well. Like, we have so many kids that end up wanting to do some crazy mechanism when they get to us, and so I'm sitting there like, we've never done that before. So do your research, you know? And so having students that have had those skills built from whenever they started, first grade, second grade, whenever, is huge. And we see them so much more successful in their other core classes too, like science, like social studies, all of it.
And you've seen even your own robotics students, just because they do robotics and they're really involved with it, it doesn't mean that they have to do robotics in the future.
No, not at all.
They've applied those skills completely elsewhere.
Right.
More things of why robotics programs are great for students. And the other program I want to talk about is VexIQ. And VexIQ is a program where every year, just like FLL, there's a new challenge. But VexIQ, what it really focuses on is that competitive drive. And VexIQ, kind of what they're seeing is they've made their own robot. So it's very similar to Lego Mindstorms, except it's their own company. And every year, kids get a new challenge, and it's a game, and it works with another team. So you get a lot of that cooperative kind of skills learned, as well as communicating with not only your team but another team that you don't know, and maybe you can make friends and build community that way. But what I really like about Vex IQ is if your area, if you know your students or your school is more competitive in terms of like sports, then Vex IQ is probably better than FLL. But Vex IQ also builds upon that project building by having like design journals.
Right.
And what design journals are is when you're building a robot, students kind of log of what they're, what failed and when they're designing the robot and how they're programming the robot, and they put that in a journal, and then they show it to adults and judges who come to the event to watch. And it's really cool. FLL, I feel like, is kind of more of a learning opportunity, especially when it comes to all those non-robot aspects, but Vex IQ is definitely great for competitions.
Yeah. Well, and we actually use the VEX systems in our engineering classes.
Oh.
So not our robotics classes, but engineering. And one of the things that I love about it is it's so, the whole system is so integrated and standardized that you can figure out how to build any sort of structure just by understanding how the parts work. And so in the engineering classes, we go through like foundational mechanical engineering and like structural analysis, things like that those systems make it so easy to build. Yeah. And so there is that difference. I agree with you. There's much more competition in the VEX system, but it also makes it so that there's much more flexibility and not as intense, complete, unique fabrication of parts, because a lot of those parts already exist, right? So it's
Correct.
like two different ways to tackle these design challenges.
And the one thing why I bring up these programs is not only have we had experience in these and we know they're great, but they both have resources on how to implement it for an after-school program.
Yeah.
So yes, you can make your own teams with your parents if they have the resources and the time. But this podcast is really trying to get into how can we create an after-school program. Both these programs online, they both have great integration for schools. First LEGO League, they have like, tell us more about your school so we can maybe deliver you the right resources when you sign up. And I think that's really important because sometimes it can be overwhelming for teachers kind of starting up their own program.
Absolutely.
I know for you, you're kind of writing your own curriculum for your current program, and I know it's a lot. So, or any teacher writing a lesson plan in general, it's a lot. So I think it's really important that having this kind of resource to have is great. But there comes with a catch. Money.
Yes.
This is probably the biggest topic that we're going to talk about on this episode, which is resources.
Yeah.
Resources is a big thing. We talk about how great both of these programs are, but it's not free.
Right.
Even though First is nonprofit and Vex, they do profit, but only to make more product for people. It's not cheap. For the First LEGO League, it's actually only $250 to register your team and compete at one tournament. But a Lego educational Mindstorm set is like $800.
Yeah.
And again, if you're watching this and you were either given a grant or your school has money, perfect. Enroll in one of these two programs. Vex IQ is like $400 for a super kit, for an educational super kit, and like $1,000 for competition and registration. So great. If you have that money, go ahead. That's awesome. But for a teacher that maybe wants to go into their school knowing that they don't have funding or they're not getting funding for proposing like an after-school club, like if they want to go do a chess club or something like that, and they go, hey, principal, I want to do a robotics club, but here's the issue. This costs this amount of money. That's not really going to work. But instead, Steven, let's say you're the principal and I go, hey, Steven, I want to run a robotics after-school program. Here are some free resources that we can use to build a curriculum, say for an after-school club. It sounds a lot better, right? So I want to ask you, do you know any free programs?
Free programs is tough, but I kind of want to answer that in a slightly different way because we've been really fortunate, and it's not just our school, it's across the state, that there are a bunch of grant opportunities right now. So the California state is offering, it's called a Career Technical Innovation Grant, or CTE-IG, Career Technical Education Innovation Grant, yes. And that is an ongoing grant system where schools can apply, especially to create new programs. So if you don't have a program yet, it's very easy to get approved. And then depending on the size of the school or the district, you can potentially get huge amounts of money. There's also Prop 28, which is a new one that we heard of, that we actually got a few years ago that the teachers weren't fully aware of. And Prop 28 is actually an art-based funding source. And I don't know how far that goes out because propositions tend to be like either slightly more local, they can sometimes be state level. That's what I'm not sure of the politics around that. But those funds can also go for a robotics program. So that's actually a way that we were able to expand our class sections to another one. And so because it's all design based, right?
Nice.
And so that's the way that there are. That question of free resources is very difficult.
It's very difficult,
days. But I think if you can figure out those other funding sources, especially if you're trying to create new programs, then you don't have to restrict yourself to free resources. You actually can get the money to then buy these other things.
Which is cool, because that is something I was actually going to ask about later, which is awesome that you answered that. Cool. So thank you for that. And yeah, it's important. Money is important. I want to just kind of touch on like resources that I found online that I just want to get your opinion on or see if you'd like. So I was kind of looking around online, and there are a couple of free resources that that maybe, you know, as long as I know having computer lab or like Chromebooks isn't free, but sometimes a lot of schools are actually getting those right now, especially in California. Yeah, Chromebooks especially. Yeah. Chromebooks especially. And all these resources that I found can be used for Chromebooks. So for example, say this teacher wants to run an after school robotics club, and the principal's like, we won't get money for it for a while. You'd be like, that's okay. I can still run a club using these resources I found online and building an after school, you know, once a week curriculum with my students open to the school. Here are some things. So for coding, one of the two main ones that I looked into was Scratch from MIT. This was the first coding exposure I had when I was a child. It's completely free. It does use two different types of languages. It uses drag and drop for young children. Command blocks, you know those very well. But you could also turn the command blocks into written code. I think it's Python. Written code, kind of see what it looks like. So if younger students don't, you know, really know how to write code, which is absolutely fine, they could do drag and drop of like, Scratch is meant for making games. So you can do drag and drop of like, oh, when the W key is pressed on the keyboard, this image moves up. Right. And then they can drag that on, and then they can look at what it looks like in written code, which I think is super cool. And it's completely free, and a lot of people that I know have used it, and that was kind of like one of the main coding ones I've looked into. There's also a lot of other resources where they kind of just have like coding resources in terms of teaching documents, like just free like coding documents, but that's kind of geared towards higher levels of education, maybe middle school, high school. And elementary school, it's more of a baseline. For example, when we talk about like those first, when we talk about like those Lego Mindstorms, even the Vex IQ kits, a lot of the main coding that the elementary school children usually use is the drag and drop features, and then also looking at the line of code. When I was working over the summer last year, we were doing a summer camp for Vex IQ, and almost every kid used in elementary school used the drag and drop coding being. So I think as a free resource, Scratch is really, really helpful. And then let's talk about designing CAD.
Yes.
CAD is not cheap.
No.
And
but there are some free options.
There are some free options. The two main ones that I've actually worked with is Tinkercad and Fusion 360. And both are really good because I know Tinkercad has some really basic designing features for young children.
It also has programming.
Yes.
You can simulate an Arduino in Tinkercad and like run it and see how it lights up and do other stuff.
Yes, that is super cool. And again, just more resources that I'm telling you guys, the viewers, that you could possibly use to help build a robotics program, unless you get a grant, which is really helpful. And then for electrical, Fusion 360 does have that.
They do.
Tinkercad
does also.
They also do have that, which is really cool. For wiring, I know it's a little bit more interesting, but a lot of things that come to mind is Minecraft Redstone. And Minecraft Education has Redstone puzzles, and people laugh at that, but
people
then
build whole computers,
and then realize that in Minecraft, Redstone works exactly as an electronic circuit, a basic electronic circuit would. It's so funny because it might help encourage students to kind of study more into it, because a lot of students do love Minecraft.
I've also heard of physics classes using because you can like launch objects out of cannons, and you can do like projectile motion analysis. You can do all sorts of stuff. Minecraft is great.
Yeah, and Minecraft Education is actually free, which is cool. Looking into Minecraft Education, I looked at like other things that kids enjoy, and I stumbled upon Lego Creations. You can build Legos like you're making your own build instructions for free. and you can put it in.
Oh, and you can order like a kit too once you finish it.
That's expensive.
Sure.
But yes, yeah. But it will show you what it looks like on the website, and it's completely free.
Right. And it'll count the number of blocks you use and keep track of everything.
Yes, and for really young children, like first or second graders who are just maybe learning their basic motor skills still, that's something you can do in robotics. Yeah. Like even just putting Legos together. Because I know some people, which is what we're going to talk about in episode 3, which is our kids too young to learn robotics. Maybe they're too young to, build and program their own robot that will do a task, but maybe they'll be in robotics to better their motor skills and put together and solve problems, simple problems, and that's something that kids will do in robotics. So all these resources are completely free. They'll be linked in the description. There's also been pop-ups throughout the video with QR codes, but that is kind of where I'm at in terms of resources. Getting the grant is something that you've mentioned, and it's awesome. And
one of the other things, just before we leave the resources conversation, I know that building, like you said, building an actual robot is hard, but starting kids young, working with some basic hand tools, just hot gluing things together, getting some like foundational understanding of structural systems and how things like fit together to then like, oh, this won't collapse or this won't do whatever, or how do I just screw in something? That's huge as well. Yeah. Right? Because like you said, the fine motor skills, we get students that I literally have to teach how to use a screwdriver as freshmen, and that's fine, but also that's something that you can absolutely do at a younger age. Yeah. And you should do at a younger age.
I agree. And just, getting kind of an understanding, because robotics is more than just building a robot. Yeah. The last topic I kind of want to talk about is just kind of like building a curriculum. Say a principal signs off a teacher for doing a 15-week program. Students are coming into this club once a week after school on Thursdays. Kind of like, what do you think is kind of like a good kind of estimate of like what those 15 weeks would look like? Like where should they be learning and what? And let's just say that they don't have a grant and they're using all these free resources. What do you think that a curriculum should look like in terms of an after-school program?
Yeah. So one of the things that we really focus on at the beginning of the year is sort of the design process as a whole. Because if students don't really know how you go from idea to product, then it's hard to try to think about all the different steps of an actual robot build. And then when you get to those different steps, even though you might say as the teacher, like, hey, we're going to introduce CAD today, CAD is used in this way, they won't really have this broader idea of how that fits in to the whole thing. So I would probably dedicate, so if you said 15 weeks?
15 weeks, one day a week.
Okay. I would probably dedicate at least 2, if not 3 of those weeks on just the design process in general and just building and prototyping things with very, very cheap, we call it found materials. So we even go like dumpster diving in our classes. We go up to the school dumpster in the front, we collect a bunch of cardboard, we literally cut it up, tape it together, like very, very cheap material, or again, things that you can just go find. We'll say if you want to bring like something from home to use, like foam noodles or whatever, if they have like pool noodles, that's fine. So you can do all sorts of stuff, do some insane design challenges, like building the tallest tower out of pasta noodles. Right? You can do with a marshmallow on top.
A bunch of hands-on stuff that elementary students would like.
Right. You can tape paper together and see if you can make like the strongest structure and see how tall you can do all sorts of things. So I'd say 2 to 3 days with that.
What about students bonding with each other, kind of like introductions?
Well, that can usually happen during
the
because you're
sure.
typically working with partners, and so then you're learning how each other thinks about these design systems.
I like the building structures for the first few weeks, because that's something 1st through 5th graders could actually do. As a class together. Like a 1st grader could just have an amazing idea of building a really tall structure. It could be better than 5th graders, and that's just how it is sometimes. Spreading ideas is the joy of robotics.
Kids are more creative when they're younger.
And what about future weeks? What do you think?
So after like week 2 or 3, then I would start to go into probably some like actual mechanism discussions, but it doesn't need to be complicated, but just something like, well, what does a wheel do? What does like attaching a chain to a wheel do? Oh, look, you don't have to actually have the motor control it from this side. So you can do some very, very simple stuff just to make something move, right? You could use tank tread to create like a conveyor belt that can move an object. You can do very simple stuff. So going into some simple mechanisms probably for like 2 weeks, and then honestly I would hit CAD for probably like 3 or 4.
Using
weeks.
some of those design resources
Yeah,
online.
either Tinkercad, Onshape,
Yeah.
Fusion. If a kid's advanced enough, Fusion. Fusion is probably a reach for a younger group, but
Tinkercad is great.
Tinkercad's wonderful, yeah. And Tinkercad is the same company as Fusion 360, so it's very easy to transfer once they get super comfortable with that.
And for
transferring into
younger
Fusion.
students, like building in Minecraft as well.
Right. Yeah. Tinkercad and Minecraft are basically like the same thing, essentially. Just obviously Tinkercad looks different.
Yeah.
So then after those like 3 to 4-ish weeks with CAD, I would probably do a little bit of programming, 3 to 4 weeks of that as well. And let's see, where are we at? 3 to 4 weeks, roughly 3 weeks.
Yeah.
So
final 3-4 weeks.
Yeah, final 3-4 weeks. Then I would do some sort of actual design challenge. Again, it doesn't need to be complicated. You could do like popsicle stick catapults.
Yeah.
You could, if you wanted to bring in some electronics, if the kids were advanced enough and they were interested enough. Because my whole, when I hear, are the kids advanced enough to do blank, I always hate that. Because every kid is advanced enough. It's just whether or not they're interested and want to do it.
Yes.
Right? So if you can offer it and you can say, hey, here are all the electronics that we have. If you are interested in including that in your project, I can show you how to work with it, right? That's totally fine, but you don't have to. So all of our projects in our classes we consider to be low floor, high ceiling. So it's a broad description of what the challenge is. And then a kid that comes in, like let's say our robotics captain who's in our first year engineering class, he is far more advanced in CAD than what that class instructs. Yeah. But I told him to take that class because I told him, you better take all those projects and just push the boundary and do crazy stuff with them. And that's all he's done.
Yeah.
Right?
But he's told me about some of them.
Right. And then he's very proud of some of them.
Yeah.
We have them on display. So, and then you have the other kids that have literally never CADed before in their lives.
But it's okay.
Yeah. And they can still do the project and still be successful with it. So that's how you got to think about all of these different lessons, is how can you get broad enough where every kid can understand how to do it, and they can do it at whatever degree of difficulty they want.
And then the most important part, I feel like, at the end of the curriculum is a showcase.
Right.
Something for the students to show, this is what I've done.
Or a game or a challenge.
And no matter what it is,
Yep.
everyone would be happy because it's something that they've learned. It's a program that's created for them, and it's showing that they enjoy it, which I feel like is really important because I feel like when students go into a program and they come home being like, oh, we did nothing. It's boring. It doesn't look well on the program. It doesn't look well for the students spending their time on that. But there's a lot of programs I know, or a lot of clubs where there's just no showcase. So, you constantly tell your parents, yeah, I'm going to this club. Yeah, I'm doing this and that. But they never get to see any progress.
Right.
Having a showcase at the end, whether it be, again, popsicle sticks, towers, how simple, how complicated, just kind of showing that they've worked towards something and they're happy with it is really important.
Yeah. Absolutely.
But yeah, thank you so much, Stephen, for that amazing information on everything and your insights. And I appreciate all the help that you do, and I appreciate the work you do for the high school students here at Los Altos.
We appreciate your help as well.
Thank you. But yeah, thank you so much. That's going to be the end of episode 2 for robotics programs at elementary schools. I again would like to thank Douglas McClure for the equipment, for the recording equipment. I would also like to thank Stephen Hine again for being on the episode, as well as Los Altos High School for letting us record here. And yeah, make sure you check out episode 3, which we will talk about Stephen's fellow 3 students, as well as some of the students I worked with, and kind of have a conversation on them about the other side of this story, which is, are robotics students too young are elementary school students too young to do robotics? So make sure you guys check out that episode, and that's going to be the final episode of the series, and hope you guys have a wonderful rest of your day.